Alright guys, hello and welcome to my demo lesson here. My name is Jeff and today we're going to be talking about the cathode ray oscilloscope. Okay, so we're going to break the lesson down into a few segments. First we're going to talk about what is a cathode ray oscilloscope. Then we'll talk about how does it work. Next we'll break it down into its individual components. We'll look more specifically at how each component functions. Then at the end we'll review some of its practical applications. Alright, so let's get to it. Alright guys, as you can see here I prepared a little whiteboard for us to introduce the cathode ray oscilloscope, otherwise known as a CRO. So first we're going to ask, what is a CRO? So to answer that we could say it is a device used to convert electrical signals to visual signals. Okay, and then next we're going to ask, how does it work? To describe the overall function, the CRO functions by accelerating electrons into an electron beam and then directing that beam onto a screen for viewing. Okay, next we're going to go over the CRO components. We're going to start with the electron gun, then we'll move to the deflectors and the fluorescent screen. So first for the electron gun here. The purpose of the electron gun is to create the electron beam. We're going to do this by heating a cathode plate. So as we heat the cathode plate, electrons in the plate are going to gain enough energy to escape the plate. Once they escape the plate, they will be accelerated towards another plate. They'll be accelerated towards the anode plate. The anode plate has a positive voltage, so it will attract the negatively charged electrons. Also, as you notice, on the anode plate there's a small hole in the center. As electrons are accelerated towards the plate and escape through the hole, you will be left with a stream of electrons through the backside, and that will be known as the electron beam. And as we said before, that was the goal of the electron gun, was to create the electron beam. Okay, so now that we've established how the CRO creates an electron beam, next we can look at the deflector systems and how the beam can be directed on the screen. So on the left here, again, we see the formation of the electron beam, and then we have our deflector segments. It's broken down into two parts here. We have a horizontal component of the deflector system and then a vertical component of the deflector system. So each plate in the deflector systems can be adjusted to a range of voltages, and that would affect the electron as it passes through differently. So for example, let's imagine that there is a small positive voltage on the top plate and a small negative voltage on the bottom plate. And let's think of how would that voltage differential affect the beam as it's passing through the plates. I'll give you a minute here to think about it. Okay, so we said that there was a positive voltage we're going to be putting on the top plate and a negative voltage on the bottom plate. Now, the electron, as it's coming through here, it has a negative charge on the electron. So the electron is negative, and we said there's a positive voltage at the top. So the electron naturally will be directed towards the top. This will result in a bend of the electron beam. So the electron beam, in this case, with a positive voltage on the top, the electron beam will then be bent towards the top. So that will result in the beam being directed towards the top of the screen. And as we pass through the second set of deflectors, we'll see the same thing. The voltage can be adjusted accordingly. We could put a positive or negative voltage on either side and use that voltage to direct the beam as we choose. So if we have control of the beam up and down and left and right, we can position the beam anywhere we would like on the screen. So here we see the cross-section view of the screen. It's easier to think of it here if we look at the front-facing screen. As we said, we could direct the beam left and right or up and down resulting in the position of the beam anywhere we would like on the screen. Okay guys, let's go ahead and do a quick review here. Just go over the things we were just discussing. So first, what were the three components we were talking about? Okay, so our first component for the CRO was going to be our electron gun. Next, we're going to have our deflectors. And finally, we're going to have the screen. Okay, so electron gun, deflectors, screen. Those are the three main components. What was the function of each? We said the electron gun is going to be to produce an electron beam. Then we're going to have the deflectors to direct the electron beam. And the screen is where we're going to project the electron beam for visual purposes. Alright, so next let's go ahead and walk through and kind of reconstruct the CRO here. So we said we started out with our initial heat source. Right? So the reason for our heat source then was going to be to heat our cathode plate. And once we heat the cathode plate, we're going to introduce enough energy to the electrons for them to escape. So electrons are going to be escaping our cathode plate here, and they will then be accelerated towards our other plate, which is the anode plate. So now we have electrons accelerating towards the anode plate, and we left a small hole here in the middle of the anode plate where electrons can then pass through the plate, and they'll come out on the back side as our electron beam. So that's our first component, was the electron gun, creating our electron beam. Okay, next we have two sets of parallel plates. And those are going to be our deflectors. So each one of the plates, we can adjust the voltage to direct the electron beam. So the first set here is going to be the horizontal plates. Those are going to direct the beam up and down. The next set here, should color this in here. The next set is going to direct our beam left and right. So the first set up and down, then left and right, and then we're going to project our beam onto the screen. Okay, and that is the complete diagram of our cathode ray oscilloscope. Alright guys, that's the end of this basic lesson here. I think we've developed a fundamental grasp and a good understanding of how the cathode ray oscilloscope works. It's also good to note here that it has a lot of practical applications. It's used a lot in the real world. Electricians, they use it for viewing the signal voltages. It's also used in medicine to display the waveforms of a heartbeat. It's even used in radar projections and in television. Thanks again. I hope you've enjoyed this video, and I hope you're interested in learning more. Bye.